Hello, welcome to my lesson. Today we will talk about vectors. Actually, we will solve problems for vectors. So this is a practical lesson, practical solving problem lesson. In order to watch my lecture about vector, please go back to the previous video lesson and watch. In this video we will practice, we will solve, we will apply what we explain it in previous lesson. Basically it was about vectors. Let me remind you, let me give you quick details about vectors. You know, all physical quantities can be divided into groups, main groups: scalar, vector, scalar, physical quantities just with magnitude, just with number, no direction. Vectors, these are the groups with direction, magnitude, and also it comes with direction. For example, velocity, acceleration, force, momentum, impulse, etc. We explained that there are some, in many books there is a special chapter for vectors, because when you add 3 Newton to 5 Newton, it will not always give you 8 Newtons. It depends on direction, so to explain it, it's better to explain in terms of separate one chapter. Let me remind you, in order to understand vector, you should be good at math, especially in geometry and maybe trigonometry, maybe. Without it, it will be difficult to understand, to solve vector problems. So please improve your math, especially in geometry, and it will be easy for you to work, to solve with vector problems. And in order to make it simple, we introduced components. Why we introduced components? Because it makes easy to solve problems when you face with, for example, more than 2 vectors. Yes, let's say you have 10 vectors, you need to add these 10 vectors or subtract. In these cases, it will be very useful to use component methods. And we choose 2 special components, and we say that it's better to make 90-degree between these 2 components. Usually we call it, one of them we call it X component or horizontal component, second one is vertical component, or we call it Y component, and the angle between them we make it 90-degree. Why special 90-degree? Because of Pythagoras theorem. Yes, so hypotenuse square equal to base square plus height square. In order to use these simple equations, it's better to make a 90-degree between 2 components. Actually, it can be any angle between these 2 vectors, because any vector is a addition, summation of any 2 vectors. Of course, it can be a summation of any 3 vectors, 10 vectors. But to make it simple, we choose just 2, and we make 90-degree between them, and it makes our life better, easy. Please follow my video, and we will solve more problems related to the vectors. First question. This question is taken from Randall. So finding the direction of motion. Figure 3.14 shows a car's velocity vector v. So we have a velocity given in terms of, let's say, graph. Determine the car's speed. So keyword here is speed. So you know, speed, the difference between speed and velocity. Speed is just numerical value, magnitude. Velocity, you should give information about its direction. So here, in order to find speed, just number, just magnitude is enough. Let's say, for example, 10 meters per second. That's all. There is no need for direction. Second question, direction of the motion. This is a second question. So first of all, we need to find the numerical value for this velocity, and in English we call it just simply speed. So we know that this car is moving in this direction. It is given with solid green line, and this is basically right triangle. So this is a height which is 4 This part, the base is 6. and as you see, this is a just simple right triangle, and we need to find this hypotenuse, and this hypotenuse will be equal to the velocity. This part is totally just geometry. So as long as we have a right triangle, we can use hypotenuse theorem, Pythagoras theorem. Hypotenuse is v square, height is 4 square plus base is 6 square. So from here we can find the magnitude for velocity. So v square equal to 16 plus 36, which will be 52. V square equal to 52. So v is square root 52. So velocity or speed will be approximately 7.21 1 meter per second. So this is the speed. No information about its direction. What is the direction? I think it's enough to find this angle, and this angle will be information about its direction. So this is a simple right triangle, so we can use sine cosine theorem. Yes, we know that tangent theta for this triangle equal to opposite side, which is 4, divided by base, which is 6, and this will be equal to 2/3. So from here angle will be equal to arctangent 2/3, and that angle will be equal to, let me do it for you quickly, 2/3, and my calculator says that it's approximately 33.7 degree. 33.7 degree. This is a direction, basically. Let's continue. Let's continue the same problem. Let's write, or let's find components of this velocity. So basically, this part, this is a vertical component, as you see, 4. This is a horizontal component or x component, which is 6. Just a number. We are talking about magnitude at the moment. So horizontal component of this velocity equal to negative 6 meter per second. Why negative? Because its direction, it is moving to the west, to the left side. The vertical component is positive 4 meter per second because of direction. 4 meter per second, it's moving upward or to the north. That's why it's a positive number. And we can also write this velocity in terms of unit vector, if you remember from my previous lesson. So we can write this vector in terms of unit vector. This is how it looks like. J. So x component is negative 6. This is a I means this is a horizontal component, and the vertical component is positive 4 j. So this is the same velocity in terms of unit vector. So this is a unit vector in terms of unit vector. And when you write in terms of unit vector, this vector contains all information about its magnitude. Also, it contains information about its direction. So usually it's better to write in terms of unit vector, in terms of I, in terms of j. Another example, challenge example. Finding the net force. What is a net force? Net means resultant force. Resultant force means addition, summation of forces. So let's read the question. Figure 3.22 shows 3 forces acting at one point. So this point can be object, but it's not important. We have 3 forces as shown in this figure acting at one point. What is the net force? Resultant force. So basically F1 plus F2 plus F3. This is what we need to find. And now it's time to study the graph, the diagram, the figure basically. We have a three forces. Let me increase the size of this figure so you could see it better. Now we have a three forces. If we pay attention, x and the y axes, they are not exactly horizontal as we used to see it, and the y component, it's not exactly vertical as we used it to see before. Is it okay? Yes, it's absolutely okay, as long as the angle between this x and the y axis is 90 degrees, so no problem. F1, first force equal to 50 newtons, second force equal to 20 newtons, and pay attention to the size. Pay attention to the size. So this size equal to 50 newton, yes, approximately maybe 3 centimeter maybe. Of course, it depends on your video screen, your computer or cell phone screen, of course. Let's say it's approximately 3 centimeter, and this 3 centimeter corresponds to 50 newton. And let's come to 20 newton, second force. It's roughly 1 centimeter, so length of this force should be smaller than the length size of the second force, of course. We also explained about it in previous lesson. And the force number 3, it's 57. It's approximately, the length size is approximately equal to the size of the first force. So this lenses very important. It corresponds, it explains, it gives information about size, about magnitude, about number. Okay. Now, what about x component and y component? I think this question can be solved by the help of the components, because we have the three forces and the different directions, and I think it will be better to solve in terms of components. And the x-y component is given for us, but in different way. It was rotated basically for 15 degrees, which is also fine. We explained this since angle between this x and y component is 90 degrees. Now let's start from the first force. What is the component? Two perpendicular vectors. Addition, summation should give us F1. So this will be my x component for F1, and this will be y component for F1. So let me write like this: F1y, F1x, and this angle, of course, 90 degrees. So very simple. As you see here, we have a 45 degrees, so it's very simple. F1x will be equal to F1y, and this will be equal to F1 times cosine 45. Let's do it quickly. F1x equal to F1y, and this will be equal to 50 times cosine 45. It's basically square root 2 over 2. So F1x and F1y equal to approximately 35.35 newtons. So this is a x and y component for first vector, both positive numbers because of the direction. You see F1x is in the same direction with x positive. So x is positive to the right side, x is positive to the left side basically. Y component is directed to the upward, so it's also positive because y is positive upward to the north, downward to the south, negative. Now let's come to the second force, F2. If you pay attention, F2 is exactly in the same direction with y. Exactly. Angle between them 0. So it's very simple. F2 has only y component, and it's equal to F2, which is 20 Newton. x component is basically 0 newtons because it's exactly in vertical or in y direction, let's say. Now let's come to the third force. Let me choose different color. So this will be x component for third force, and this will be y component. So this is F3x, F3y, and here we have a 90 degree perpendicular. So if you look carefully, you can notice that. Let's continue this line and this line and this line. As you see, this is a right triangle, so this angle will be 75 degrees. Yes, 15, 70, 90 degree. So this angle is given for us. It's 75 degree because 95, 15, which is 75. So this angle, let me write with different color. This angle is 75 degrees. So again we have a right triangle. Right triangle. In order to see it better, let me draw it in different way. Let me rotate this right triangle basically. This part is F3, F3x, F3y, and if I'm not mistaken, this angle is 75. This angle is 75 degrees. Yes? Now we can continue. So you can see that x component equal to F3 times cosine 75, which is 57 times cosine 75, and it will give us 57 times cosine 75, 14.75 newtons. Now let's come to the y component. F3y equal to F3 times sine 75, 57 times sine 75, and finally we will get answer, which is 55.05 newtons. X component, y component. Now we need to pay attention to the signs. Yes, so as you see, x component is in the same direction with the positive direction for x, so it will be a positive number. And the y direction, pay attention, it's going downward, it's going to the south basically, so we should not forget negative sign in front of the 55.05 because of direction. Now question was to find resultant force, net force. So basically F net, F1 plus F2 plus F3. We decided to solve in terms of component method. So basically F net, let me write like resultant forces R, it's better, just one symbol. So x component of the resultant force, net force, equal to F1x, F2x, as you know, plus F3x. So x component for first force is 35.35. For second force it's 0. For third force it was also positive, and 14.75. So x component for resultant vector 35.35 plus 14.75, 50.1 newtons. This is the resultant vector's x component. Now let's come to the y component. Ry equal to F1y plus F2y plus F3y. F1y 35.35. Y component for second vector it was 20. And y component for third vector it was negative 55.05. So finally answer will be Just let me use my calculator quickly. 0.3. 0.3. It's almost 0. Yes, it's almost 0. I think it's 0 because we rounded numbers. Yes, when we multiplied by cosine, sine, we rounded. Okay, it's not big problem. So finally, we have a resultant vector. We can write in terms of a unit vector. So finally, 50.1 I plus 0.3 j. This is a final answer in terms of unit vector. We can also draw it in terms of diagram. Yes, in terms of graph, let's say. And let's come back. Let me draw the original x and y axes. Approximately, this is how it looks like. Y. 1 second. Yeah, it should be 90 degree. Yes, this is almost 90 degree. This is a y direction. This is the x direction. This angle is 15 degree, 19 degree. Now we need to draw our resultant vector. X component is 50, so let's say 3 centimeter approximately. This is x component till here, starts from here, ends here. And y component is almost 0, 0.3. It's very small. So actually this is how it looks like. This is a resultant vector. R vector. Of course you can find this direction, but this angle is, as you see, very small angle. Let's call it alpha. We can find this angle. So tangent alpha equal to resultant vector's y component. You need to divide by x component of this resultant vector. So this part is y component, this base is x component. So 0.3 over 50.1, I'm sure it will give us very small angle. 1, so it's 0.006 approximately, which is arc tangent 0.006 equal to 0.3 degree, 34 degree. You see, very small angle. So we have a next question, next problem. As you see, 4 different parts, 4 different problems. Sub problem, we can say. Let me solve only first one for you. Other 3 ones, which is B, C, D, will be your classwork. So you need to submit it today via Google Classroom. So let's go, let's start. First question, A. Draw each of the following vectors, label an angle that specifies the vector's direction, then find its magnitude and the direction. So we have a B vector, negative 4i plus positive 4j. So this is basically x component, bx equal to negative 4. This is a y component, positive 4. You can quickly draw. X component is directed to the left or to the west. Y component is directed to the north or to the upward because positive number. So approximately this is how you should draw, because x component is negative, y component is positive. And if you pay attention, this is a 4, y component is also 4, 90 degree. It's obvious that this angle should be equal to 45 degrees. There is no need to solve. Yes, simple, very. So this is a direction, 45 degrees, as shown in the figure. Now it's time to find magnitude. So basically it's the length of this part, the hypotenuse. Again, we will use Pythagoras theorem. B square equal to bx square plus by square. And we know that bx equal to by in terms of number. So b square will be equal to bx square. And from here, b is square root 2 bx squared. So b equal to bx times square root 2. So, and this will be final answer, 4 square root 2. This is a magnitude. This is a magnitude. And B, C, D, this question will be your classwork. You need to submit it today via Google Classroom. Similar question, this is also your class work for today. Next question about unit vectors. Vectors are given in terms of unit vectors. Let's solve it. A vector, B vector we have, and we need to find C plus B. So we need to solve it in terms of component form. This means unit vector. So A vector equal to 2i plus 3j. As we said before, 2 is the x component, 3 is the y component. Ax, this will be ay. Now let's come to the second vector. B vector equal to 2i minus 4j. So this is a x component for B, this is a y component for B. As you see, it's a negative number. So we need to find C vector, which is A plus B. A vector plus B vector. As you know, first of all, let's solve it in terms of components. So Cx equal to Ax plus Bx. Ax is 2, Bx is also 2. So x component for C vector is 4. Now let's come to the y component. Ay plus by. Y component for A is 3. Y component for B is negative 4. So C vector is negative 1. So we found components for C vector. Now in second part it says draw a coordinate system and on it show vectors A, B, C. Okay, so first of all let me finish the first part. So C vector equal to 4i minus 1j. Yes, there is no need to write 1, it's just 1. So now second part, we need to draw a coordinate system. As usual, x is to the right side positive, y is positive to the upward. So this part is 0. A vector 2 and 3. So let me say each square is equal to 1 unit. So A vector's x component is 2 units, B vector is 3 units. So this is our A vector. B vector, x component is 2, same here. Y component is 4, negative 4. Minus 1, minus 2, minus 3, minus 4. So this is our B vector. Now let's come to the C vector. X component is 4. So 1, 2, 3, 4. X component is here. Y component is negative 1, which is here. Yes, minus 1 basically here. So this is our C vector. Now last part. What are the magnitude and direction of vector C? Magnitude is very simple. So C vector square equal to x component square plus y component square. So x component is 4, y component is -1. -1 is not, negative sign is not important because of square. So c square equal to 16 plus 1, c square equal to 17. So c equal to square root 17. So it's approximately 4 point something. 4.1. 12, let's say. This is magnitude for c vector. Now let's come to the direction. So basically, let me zoom it. We need to find this angle. Yes, alpha. So again, as you see, as you know, it's a right triangle here and here, 90 degree. This part is 1, x component is 4. So tangent alpha equal to opposite side 1 over 4 base, which is 0.25, and from here we can find angle. Arc tangent 0.25, which corresponds to which angle? Let me check. 14 degrees approximately. 14 degrees. So this is a direction. This is a direction. And these three questions, question number 13, question number 14, and question number 15, will be your homework for practice. Practice makes perfect, as you know. We need to practice. You need to practice. So 3 problems. Previous ones was classwork. Don't forget, these ones will be your homework. You know how to submit. Of course, we are Google Classroom. Thank you for watching my video lessons. See you. Bye.